Is the moon still geologically active? Evidence says it's possible. Wrinkle ridges that formed in the past 160 million years suggest recent geological activity on the moon. The moon may still be geologically active, judging from the way the lunar far side is wrinkled as the moon contracts. At least that's what planetary scientists who have discovered 266 lunar wrinkle ridges say, as all of these ridges appear to have formed during the past 160 million years in the rare volcanic plains on the lunar far side, the dark side that we never see. Knowing that the moon is still geologically dynamic has very real implications for where we're going to put our astronauts' equipment and infrastructure on the moon, said one of the scientists, Jessel Clark of the University of Maryland, in a statement. Wrinkle ridges are well-studied phenomena on the lunar side, the face of the moon that we can see hanging in the sky. The near side is characterized by the famous man in the moon, the pattern created by large dark patches called lunar maria. The maria are vast, solidified lava plains that formed between 3.2 billion and 3.6 billion years ago from volcanic activity. As the moon's interior cooled, that volcanic activity dried up and the moon began to contract. This led to the lunar mare basalt, dark volcanic rock, wrinkling like the skin of a shriveled old apple. The near side wrinkle ridges are huge, stretching from tens to hundreds of miles long and standing hundreds of yards tall, a testament to the titanic geological stresses that formed them. Yet, whereas 31% of the surface of the near side is covered in maria, lava plains are found only on 1% of the far side. Planetary geologists are not sure why this is the case. One theory is that a dwarf planet more than 435 miles or 700 kilometers across and loaded with radioactive isotopes struck the near side long ago, ejecting large amounts of debris and eventually settling into the far side of the moon, thickening the crust there and making it more difficult for volcanism to burst through to the surface. Meanwhile, the radioactive isotopes were deposited on the near side, where the heat they produced from radioactive decay melted the rock, facilitating more volcanism on the side of the moon that faces our Earth. The result is that the far side has very few maria and so does not have the long wrinkled ridges that the near side has. However, using images from the narrow angle camera on NASA's Lunar Reconnaissance Orbiter, Clark and fellow researchers Cole Nipavar and Thomas Waters from the Smithsonian Institute in Washington, D.C., have identified 266 wrinkle ridges in far side maria. These far side ridges are all smaller than the near side counterparts, about 328 feet or 100 meters wide, and about 3,280 feet or 1,000 meters long. They appear in groups of between 10 and 40 in the far side maria, which are also much smaller than the near side equivalents, but it's their age that's the interesting thing. Although it's assumed that the far side maria formed at the same time as the near side maria, the far side wrinkles seem much younger. However, you can't just ask features on the moon for their age. Geologists have to employ clever detective work to get those answers. Planetary scientists count craters, for instance, the logic being that older features will be covered in more craters than younger features will, while younger features will overlie or cut across more pre-existing craters than older features do. According to crater counts, the far side wrinkle ridges are between 84 million and 160 million years old. That means that volcanism on the far side must also be relatively recent, certainly in the past billion years. Otherwise, the wrinkle ridges would have formed much earlier. Many scientists believe that most of the moon's geological movements happened 2.5, maybe 3 billion years ago, said Clark, but we're seeing that these tectonic landforms have been recently active in the last billion years and may still be active today. There is supporting evidence that corroborates this startling conclusion. In 2020, the Chinese Chang'e 5 mission brought a sample of lunar material back to Earth from the vicinity of the moon's Rumker volcanic domes in Oceanus Procellarum, which is a vast near-side lunar mare. Analysis of the sample found volcanic glass beads in the lunar regolith that have been dated to 123 million years ago, give or take 15 million years. If true, then this geologically recent volcanic tectonic activity means that the moon is still contracting as heat slowly leaks out from its interior, and that volcanism might still be happening today. The moon's contraction could lead to the moonquakes that seismometers place on the lunar surface by the Apollo astronauts, and they have detected. If moonquakes are severe enough in some parts of the moon, then they could pose a hazard to human activity on the lunar surface, leading to astronauts having to avoid those locations. And the findings were published January 21st in the Planetary Science Journal. And this is originally posted on space.com. It's by Keith Cooper on Live Science. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.